Hi, this video is going to take you through the MasterFrame tutorial on basic analysis to Eurocode 3. It is written for the 2018 version of the software and I'm running 2018.16. So, start the Master Series, we come into Frames, MasterFrame. We then have our file selection menu. I'm in my correct directory and these are existing files which give me a get function. If I click on the new button, I can type in the name of the file, tutor01, and this changes to a create. So we're now going to create the file and we come to our preprocessor. I'm going to choose the multi-story as it is the closest to what I want, and I'm suddenly going to turn on the member lengths, and I'm going to place the cube in front view. If it was in isometric, I just click on front. So change the number of spans just by clicking on the label to 4. Number of stories is 3, that's okay. The default span I'll leave as 6, and heights. Span number 2 I will change to 7 meters. Span number 3 I will also change to 7 meters, and I will just leave all the others blank because I'm going to apply load directly as a teaching purposes and say apply. So putting it in the front view, it's in red because it wants to show all the different colors of the sections. I'm just going to change that to not color by section. So nice, clean, fine wire lines. Let's have a quick run through the toolbar on what we need. We have the undo and the save. We then have our member information such as section sizes, lengths, and the member numbers. They're going to be used. And under nodes we have the node numbers and the X, the Y, and if we had a 3D frame, Z coordinates. Under supports we can display our supports or hide our supports very simply. And then under 3D we have the 3D button. It's got generic section sizes because it doesn't know what the section sizes are, and you then have the color by section. If they were all different sections sizes, they would be colored. And just turn that off, turn off the 3D. Also of use sometimes is the draw short, which shortens everything so I can see what's a continuous and what's a individual member. Then we have the loading diagram, which we will also be using. We won't be using the gravity or wind loading. This is a basic tutorial, nor grid lines. We may use one or two of these eventually. So let us manipulate some of our members. I'm going to turn off the member lengths as suggested, turn off the supports. I'm going to turn on the node numbers, so number nodes. So I just close that, and now I want to manipulate the frame. So I go to modify, so I'm changing existing, and go to move members. Now what I want to do is to select any one of the members at the end of node 18. It's highlighted, and then I want to tell it to move member ends and to move all connected ends. So that means they all move. These 3 members will all move, and I just say, just minimizing that so I can get and see it. I want to shift 2 meters, quick preview, that's what I want, and apply. So now what I want to do is put this onto a straight line. Now I could work out the distance as a ratio of 6 to 7 over 13, but instead I'm going to go in and use another tool, modify position on a straight line, and all I want to do is to window using a dragging motion 1, 2, 3 nodes on a straight line. Now I don't need to tell it anything else because it automatically will assume the start and end nodes, and I want them to be retaining their X coordinates, so this won't move out at an angle, it'll move out vertically. And I can say preview. So if I had this perpendicular to line instead, it would have moved slightly to the left, or if I had set equal spacing, it would have been a wee bit awry. Sorry, keeping physical members is the one that's holding it back. So turning off the alignment, if I went to equal spacing, you'd see it's moving slightly to the right. If I had perpendicular to the line, it would move slightly to the left. So the one we want is X coordinates, and the other two will just leave on by default and say apply. I want to now repeat this for the far side, so reset and add in these, and again it'll assume the nodes, and I'll say preview, yes that's correct, apply. So now what I want to do is add some diagonal bracing into the first bay. So we're now creating additional members, so create add members. I'm going to choose the section, and we're going to choose it to be a flat, and I will make this a 100 by 10 in grade 355. It's going to be a bracing member, so we might as well tell it's a bracing member, and it's going to be tension only. You can include release ends, but tension only or automatically releasing in the ends because that makes sense. So I want to go then straight away from 1 to 7, and then I'll do continuing 2 to 6, 6 to 12, 7 to 11, 11, 17, 12, 16. So that's all of those members defined. So let's remove the bracing and the tension only, and we're now going to add in two additional members out here which we don't have any access to get yet. So I'm just going to go into my settings, and my grid is going to be 1, zeros and zeros. My object snaps are going to be all turned on bar this one with the snap distance of 0.1, and my tracking is going to be 30 and no custom angles, and I will keep these on and tracking line snap spacing and say OK. So let's go back to front view, click in node 16. So now we're going to get all these different projected lines depending on where we go. So I'm just going to move to the left, and it's going to project as a continuation of the rafter, and I will type in 1.5 and enter. I will do the same over here and project on out 1.5 and enter. So additional members, very straightforward and easy. So just save that while we're working, good practice, and I will turn off the node numbers, I don't need those. So we're going to put some section sizes. We have some sections on the two cantilevers plus the bracing because we defined the sections in those as you're working. But we're going to put all our sections on. So properties, members. So as you can see, there are three objects. There's the member section properties, the loading, and the rotation. There are also three methods on this one member. on all members that are globally the same. So if I was to click on this bracing, it would highlight all the bracing members because they are the same section size. Noting that at the minute I also have the same section size in the two cantilevers, but we'll define those in a minute. And then you have the copy mode to copy the current definition onto other members. So back into member mode. So first and second floors are going to be 457 by 52s. So turn on members and pick member 1. Change the steel section from a flat to a UB from 914 to 457 by 52. That looks better. And obviously also grade 355 in my case. So now we want to copy that onto members 2 to 8. So what I can do is I can go to copy mode, and I can now window this directly onto these members. I want to now do the rafters, so I'll remain in copy mode. While I'm in copy mode, I can modify and change these parameters because this is like a palette, a template. So I'm going to change the section here to 406, sorry, going downwards, not upwards, 406 by 39, the lightest again of those. So nothing's highlighted in red because no members use that section. And I'm going to copy that onto all of these. And if I just window carefully, I'm able to do all of those rafters without touching member 25 because I haven't gone through the center of member 25. And it's asking me to wish to replace them because those two members as the cantilevers already have a section defined, and I'm going to say yes. So that's them done. So now we look at the columns. We're staying in copy mode and we're just changing from a UB to UC and down to the lightest, and we're going to work with the 30 kilogram and apply that to the outer columns. So window and window. The others will think they're the same because they have no definition, but as soon as I start to work with the inner columns, I'm going to make them 152 by 37. So the next weight up, and I'm going to just window these gently one at a time. So those are all the same section size. So if we now turn off the member numbers, turn on the section sizes, we will see the 39s, the 52s, the 37s and the 30s. Now we don't get any grades written after these because the 355 is the default grade, so it just makes everything a lot smaller. And just save that as we work. So now we want to add some loading onto the structure. So I'm going to turn off my section sizes, put my members back on again, and go to loads and member loading, loading directly on members. So again, I'm going to remain in copy to mode, and I'm going to turn on the frame loads so I can see them, and I'm going to change this from dead plus live to all loading cases. And I'm going to ensure that I have the right settings. So I'm going to have all of these turned on, all of those, and that one, but not density. We don't need to see the density. We know it's there. So we can either minimize it down onto the bottom, and you will find it's still there, or we could have just dragged it onto a second screen. So now we're going to apply this. So bear in mind we're in copy mode, so that what I do has no effect until I actually paste it. So 2 UDLs. I'm going to make the first one a D1 of 25. I'm going to change the second one to a live load group, so L1, and I'm going to make that 28. So now I'm going to copy it onto all of these. So 1, there it comes, 2, 3, 4, 5, 6, 7, 8. Now, if I just pop that back up again, I can change the scale down or up as I need and just minimize that. So now I'm going to edit this palette and reduce the dead load to 12 and the live load to 4.5, and I'm going to put this onto the 6 roof members. So again, very gently ensuring you don't capture that member. If you do put a load onto a member by mistake, you can just click on it again to remove it. As you can see, this is no longer on here. If I go here and copy it, it comes back on. So now we're going to put an individual load onto member 2. So back to member mode, and we'll go to member 2, and I'm going to put a partial trapezoidal load. And it's going to start with a value of 30 kilonewtons, end with a value of 30. So there it is. And it's going to start from 2.1 to 5.5 meters. So from 2.1 to 5.5, and as you zoom in, you will see that it's showing up there as a partial UDL. Now I want to apply our wind loading onto our structure. So in member mode, let's go to member 13, the first of the columns, and I'm going to apply 2 UDLs. The default direction is Y. I'm going to change that to X, and cursor here, X, and I'm going to put them into 2 groups, W1 and W2. So the first load is going to be plus 5.5, and the second load is also going to be plus 4.8. Now that second load is incorrect, but as it says in the tutorial, we will actually correct that later, and we're using that to demonstrate how to find these errors. So now I want to go to copy mode and apply that to that member and that member. If I wanted to tidy this up, I could reduce my font down to say a 10 point and get things written a wee bit neater on the screen. Now I want to do the right hand side, so I'm going to change these two values to plus 1.8 and plus 4.8, which on this side is actually correct, and I can actually just window them rather than doing them one at a time. So that's all my loads. Play safe, go back to member mode, don't do no damage, and I'll just turn off the member numbers, don't need those anymore. Density is automatically applied. If I go to density and set weight, you'll see that it's included as a D1 load, and it's classified depending on the stiffness of the member, and therefore it's going to come through as 77, or the density of steel. So now what we want to do is to create some loading cases, but before that we need to make sure we're working to the right design code. So under design code, we want to make sure, if we were working to British design code, we go to Eurocode, yes, and it's now going to ask us to choose between the two sets, and I'm going to go for the more simplistic 1.35 and 1.5 rather than 1.25 and 1.5 plus the following. So I'm going to say OK, and now I'm going to give my load groups some names. So loads, So a wee bit of reverse direction here. We should maybe have done these first. So load groups, D1 is called dead load, L1 is live load, and W1 is wind load. So I'm going to modify that wind load on side, and that's a variable action. If I want to look at the W2s, I just drop the list and I modify those to be wind load on gable. The G-inf over G-support is 1 because we're going to assume that there is accuracy in the calculation of the dead loads, the permanent loads. There's no probability in the thickness of the materials, particularly for steel work. So now we're going to create our loading cases. So let's go and go to loads, loading cases. And our first case we can see is dead plus live ultimate, and our second case is live load only. We're going to create some more loading cases, 3 more cases. So I'm going to go add, and I can type in dead plus live on wind. Dead plus live plus wind on side. And then I'm going to create another loading case, and this time I'm going to use the keyboard to go dead plus live plus wind on gable. And then finally we want a 5th case of dead plus live surface. So I'm just going to go dead plus live, and if I want I can say surface. Okay, 4 loading cases. I want to just sort them. So what I will do is I'm going to go to that one, and I want to just move that down so it's near the bottom. Oh, not up, down. So it's loading case 4. So I have 4 and 5 are my 2 service cases. And let's play sensible and put the word ultimate after each of these, just to keep things nice and clear. Okay, let's look at our loading combinations. So let's go to the combinations, and we will see from loading case 1 we have 1.35 and 1.5 already. Loading case 2 is dead plus light plus wind on side. So I'm going to go for, and I can use these shortcuts, and wind is the least dominant, put in as 0.7. And then for the next one we're going to go for 1.35, again 1.5, but this time we're going to use W2 for wind on side. And then for loading case 4 we've got live load only, that's fine. And for loading case 5 we've got dead and live of 1. Naturally, if we were being accurate about things, we'd actually swap these 2 values around to check that the other way around isn't more dominant. For each of these we create additional loading cases. So we'll save our work so far, and what I want to do first of all is to turn off the load diagrams. Just push that out slightly, turn them back on again, that refreshes all the data. And now what I'm going to do is flick to all cases, so they're on factored loads, but then we will look individually at the dead loads. They look good. The live load looks good. The wind load, and I might just want to magnify those up, is blowing left to right. That's correct. and then W2 is not correct, so they should be blowing outwards as a suction load. So we will see that those are incorrect. So what we want to do is to go to the loads editor, so loads, member loading. If I choose this member here, for example, and then say global mode, we will get all three of those columns, and we can change that from plus to minus. It updates itself and everything is now correct. So while we're here, we can then say, well, what are the combined loads? So all loads, loading case 1, dead plus live, and we'll just reduce the scale. So dead plus live, put it over here out of the way, is looking good. And if I just middle mouse drag that down a wee bit, that's better. Obviously that includes no self weight. Put on the self weight and we'll get a slight increase. So dead plus live ultimate. That is dead plus live plus wind on side, dead plus live plus gable wind, serviceability, and that's us. So now what we want to do is look at our foundations, our restraints. So in reality, we've been working here across the screen, across this, and we go to restraints, and we go to nodal static restraints. So there are three basic types of restraint. There's the pinned, there's the fixed, and there's the roller. And then there's also the other, where you define your conditions and the little red dots tell us the directions that are restrained. So if I had vertical only, it actually shows up as a roller. But if I had vertical with moment resistance, you'd see that it's directional is only the Y, but rotational is all of them. So it's like something stuck inside a unusual arrangement. So let's change them all back to fixed. So fixed. So now let's analyze the frame. We've got enough, so we've worked our way across, and just go straight forward static analysis. And it's a plane frame. Having analyzed, obviously the next thing to do is to look at the results. So graphical results, and we will see straight away bending moment diagrams as we expect. We can change the scale from 1 to 50 to 1 to 100, and we'll also choose major axis only and show values. So we're seeing now the values on the members. It's quite easy to print, so if I just go to print down here, I can then set up my arrangement and put in my data and print straight to my PDF writer or my document. I'll just close that, exit and close the graphics. So we also have our text results. So under results we have tabular results, the numerical values. So looking at it, we have nodal deflections, and it automatically goes to service cases. So we can see our nodal deflections, and while I'm here, if you looked at support reactions, you can see those again, their serviceability. You can ask for ultimate values and I'll give you those. You can ask for all cases, and in that case you might say give me the maximum values of support reactions. So maximum ultimate or maximum support reactions. All cases would actually require me to select them. And naturally you have your member forces as well, and all the detailed information that is available in the manual on output. So now what we want to do is the modifier frame, because we can't have a column here, we're going to put a column either side. So we're going to put a column down here and a column here. So we're going to create this using the create column rather than create member. So add columns, and we're immediately going to change its section by going to in use and choosing the 37 that's available. We're not going to change anything else here, except if I minimize that, I'm going to say height from point 3.5 meters and below. So member 3, let's put on our member numbers. Member 3 from the right hand end. If we then move across, we could move out to 2.5, but that's quite hard to pick because it's close to 2.33, which is the third point. So all you have to do is either zoom right in until you get it at a reasonable resolution, there you go, or just go across and type in 2.5, just like AutoCAD, and in comes the column. So we'll now put the other member on the other side, 2 meters out. In this case, I've managed to get a good snap on 2 meters, and it's in. So now we've got 3 columns, we need to get rid of one of them. So the correct way is modify, delete members, select the member you want to delete, there it is, and say apply, and that member's now gone. We could have actually deleted it just by drawing it in a second time. So now we need to fix the connectivities around this area. So what we're going to do first of all is to draw all the members short of their nodes, so we can see that it thinks this is one member and this is one member. So we need to actually unattach these and make this one member across here. So we're going to go to modify, so we're changing existing geometry, and we're going to split members, and we're going to select the 2 members, 4 to 5 and 6 to 7, and we are going to go and select the explode option. So the method is explode, and say apply. So clear our selection, and we now have 4 individual members. So now what we want to do is to glue the 2 components, not split, merge, and I want to merge this member with this member, and I can say apply. So I now have member 5 to 6. I could have done a quick merge as well, which is just point to point. So we now need to check our supports again. So just turn off our member numbers and look at our supports. We have fixed here, we have pins here. So let's go and make this consistent. So restraints, static supports. So I'm going to go from the first to the second group, which is the pin group, and I'm going to delete those. So now I have one group. I'm going to add these 2 into that group, and they're now all fixed. So we'll now save the file again, and we will exit MasterSeries. So File, exit MasterFrame. Okay, so we're back out. Now we're going to come back in again for the next part. Frames, MasterFrame, and we'll find our file tutor01 and get file. Now before we go on, we want to introduce 2 new facilities. because we're going to do a steel design, and that is to deal with vertical imperfection loads. So we're going to introduce new loads, new loading cases in fact, so loads, and we'll just go to notional horizontal loads, horizontal or equivalent horizontal forces depending on the code of practice you're used to. Same thing. So load directions I'm going to set to 0 and 180, and I'm going to find this, and I'm just going to generate. And it has created two more loading cases of dead plus live, notional, and each of the two directions. It does it in two directions because the frame is asymmetrical, so therefore you're always better to do it in the two opposite directions. So we'll be able to use that later on to check our frame stability, or lambda crit values. So before we go and analyze, we just need to look at the continuity of the joints. We're going to pin some members. So turning on the members, go to the restraints and member end releases. So I'm going to select major and minor axis only. I'm going to click and release the top of the two columns. I don't want moment coming through. And I'm going to select to pin the bottom of this column. To speed up our design process, we're going to now introduce some member viewing groups. So under viewing, member viewing groups, we're going to create some first. So external columns, EXTR, and then change from search to add, and we're going to add these outer and that one because I didn't get the center of the member columns. Now I'm going to do another add, and this is going to be inner columns. And I'm going to select these three, and these two. And then I'm going to add another group called single story columns. And I'm going to add those two. Now I'm going to work on the beams. I'm going to add in outer beams. Sorry, 1 to 8. And I'm going to put 1, 2, 3, 4 members in. And correct the spelling. Add in the next one called inner beams. And add in those two, those two. And finally, for the beams, add in a transfer beam. And select this member and this member. And now we'll add in another group for the rafters. And finally, bracing. So let's reanalyze again. It's a plane frame. Back into, can I move this back into front? That just recenters it all for me. And now go into results, graphical results, turning off the member numbers, we don't need those, and into bending moment diagrams. As you'll see, the considerably larger diagram, and we'll need to just change our scale here to 1 to 200, popping on the values for major axis only. So we appear to be getting same answers as the tutorial, that's good. And then on deflect it with geometry, whoops, and set the magnification factor not to 1000 but to about 1 to 20, and we can see we're quite sensitive around this area, so we may need to increase this beam. What we can do at this point in time is to show the nodal deflections. See, we're dropping down 19 mil. Obviously that's clearly under ultimate load, but that still gives us an idea. And we know the frame is behaving as expected. If you look at the service cases, we're up to about 13 mil here, which is still a reasonably considerable drop compared to the rest, but may not be that significant. So we're now ready to do our steel design. So design, steel member design. We have two different methods to integrate it in auto design. We're first of all going to use the old-fashioned integrated and go and choose auto check, group check, and then window that on all of the members, and they all get included, and we'll see now that quite a few of the members are actually failing. Not that useful these days, but it's worth showing you. So now I'm going to go in and add in an axial with moment, which is the general check you do, and make sure we're in apply mode. So I'm going to apply that to member, not member 1, but member 3. So here I go. I have my member failing ever so slightly, and I can see also that I have OK axial, but its local capacity and its buckling is failing. So what I'm going to do is now teach this a wee bit more. So go to axial with moment tab and tell it that it's a beam that is fully restrained, so full restraint. And now most of it works, but it still has a local capacity problem. So back to the section design, auto design tab, and I can change up from the 52 to the next section, which is the 60 kilogram, and we get no failures on the screen, so it now works. Push that back down for a second, down to the 52, and click on the auto size current member, and it automatically finds that section. Now that will actually work no matter where you are. It'll size it. Even if I was way over designed, it will still start at the bottom and walk up. It is walking up in depth, serial size, but I can actually ask it to walk up by weight order instead, which means these are all relisted, so they're going up by kilograms rather than depths, and the auto size will actually find the same section. Does still work in this case. So what we want to do is now look at doing them all, and we could go through and apply each one manually, but there is a far quicker way. I'm going to first of all delete this check, and I'm actually going to delete the auto check as well, so I have no design checks, and now come up and say automatic multi-story continuous, and it's given me 37 checks on my members. 34, 38, 37 checks because that's a single member, those two. It's also switched me over automatically to search mode, so I can now look at any individual member to see what's happening. So I can click on member 5 to 7, sorry 5 to 6, and see that it's failing miserably. So I'm going to design these all not individually but in groups using my member viewing groups. And these are available in the Auto Design tab when I ask to use the Advanced Auto Design. I get this additional set of lists. So make sure sort by weight's on. Yes, it is. It's got a rectangle around it. And I'm going to go first of all to external columns, and I'm just going to say Auto Design. One member, all members but different sizes. So if I do that for those three, you'll see that that's a 30, that's a 23, and that's a 23. Or auto and all the same section size. So we're going to use all the same section size. It just confirms all that to me and comes back. I now change to internal columns, repeat, confirm, and it's done all those. I now move to the next group and repeat and confirm. And outer beams, Auto Design all the same size. And the reason I ask this because it could be that the 4 beams in this case could be UB, UC or SJ, but we'll make them all the same shape and all the same grade, so it's just a confirmation of that. Inner beams, sorry, yes, and then we have our transfer beam. Doesn't really matter which one of these you use, there only is one member. Now we're moving on to the rafters, which are slightly different. If we go to the rafters and we go and highlight one of them, any one of them, probably one of the bigger ones, we need to change the restraint conditions to be from fully restrained to 1L, and then we need to introduce intermediate lateral restraints. So turn off auto restrain and set this value to 1.8. So that's going to assume that we have 1.8 meter centers across the span. And now I'm going to copy that using the copy mode onto all of these. And the beauty about this is it doesn't create additional design checks. It just updates the ones we already have. So back to search mode, and we now see we have individual members. So having set those correctly, we can now auto size them all to be the same size, and they're all now 305 102s. And then finally into the bracing, which is flats, and I'm just going to make sure that they're 1L. So 1L, just going to copy that onto all of those, and then back in search mode, auto design all, and 355, yeah. And we should find we get away with the 100 by 10 throughout. So now, having done all that, because of the determinant frame, we need to reanalyze. And having reanalyzed, we're going to go back to all members, and we're going to use this button here to scan for any members that have failed due to the changes in sections. So one member is failing, and it is just a wee bit of a transfer due to the stiffness changes, and we just need to size that up again. I'll just size that one member up to the 82. So now what we want to do is to check that the frame we've analyzed, just analyze that again with that corrected section size, scan again, and that's fine this time. We want to check what our elastic critical load factor is, so we want to add another final check on elastic critical load factor, and it tells me that I do need P delta on these loading cases. So let's go to edit frame, save the data absolutely, and then from the analysis menu select second order analysis options. In loading case 1, we're going to turn on P delta, and we're actually going to use the geometric stiffness matrix. It is a braced multi-story style frame, so the geometric stiffness matrix is a better approach than the Newton-Raphson. So we can repeat this for each of the ultimate cases. And in reality, you would probably also consider it in these two cases, because if it's not significant, it will have no effect. So analyze again, static analysis, back into design, steel member design, and go to our elastic critical load factor check, which is in fact at the very bottom check on the frame. And we'll see now that everything is okay. Yes, we need it, and yes, we've done it. So what we need to ascertain now is, have we actually caused any members to fail due to this? So the easiest way is to come down and if we go to another design checks first, easiest way to get here, and ask to scan for failure, since we've already analyzed, and say yes, and we find that we have no significant change in forces. And that is your frame designed. What I'm now going to do is move on, and for the benefit of people who have MasterFrame Pro, with the Pro features, we're going to make use of member design groups, which are more flexible than ordinary groups. So under design, we go into steel member design groups. Put this in the front view. We don't really need the member numbers, and we are going to go and have a group called external columns, which will be axial with moment. We ensure that nominal moments are on, and we will change all the data and properties for the same, and we will, in copy mode, apply those and those. We'll then add another group, and we will repeat the same criteria and just abbreviate internal columns, those, and those. The big difference between these and member viewing groups is that in member viewing groups, a member can be in several viewing groups. In here, a member can only be in one design group because we're defining how we want to design that member. So the two single columns, add those two in, change data. Now we're going to do the beams. External beams, 1, 2, 3, 4, and we're actually going to do an appendix G at the same time, slightly more onerous, and we're going to tell it immediately that it is fully restrained and change data. Okay, and now we're going to repeat for the internal beams and then the transfer beam. With appendix G, full restraint, and on and on. So that needs to be on. And then transfer beam is this pair together, and it's going to be 1L, actually with moment, nominal on. Well, it doesn't really matter because it only is the single member. Now we get into the advanced power. So when we come in and do our rafters, we can again ask for an axial with moment. We can add in the members we want, and it's 1L this time, but when we scroll down we tell it that portion 1 is equal to 1.8 meters. Now beyond these portions we then have the information for the appendix G condition. So my first portion, I really want to check from eaves out to the midpoint, and some of the members are 6 and some are 6.5 meters or 7 meters, so I'm going to put in 3.5 meters as my length to the center, so it'll be okay for all of them, and change them for the whole group. And then I'm going to come along and add in the final group, bracing, and I'm going to put in these, and these. I am going to say that it is in fact not axial with moment but a strut and tie check, and the strut and tie we're going to assume that we have in our web one hole that is 22 mil, so that we will allow everything to be satisfactory. And that's it. We go into design, steel member design, and I'm going to first of all delete all my design checks. Delete all checks, yes. So I have 0. I'm going to add back in my elastic critical just so I have it, and then I'm going to come in and ask for auto, and it doesn't matter which one of these I choose, simple or continuous, it'll automatically put them in correct for that member. So it'll automatically make these strut and tie. it'll automatically put these in with the restraints at the 1800 centers. Everything is all automatically done. And then from the auto design toolbar, I just come along and say size them all individually. Again, that won't matter because it will automatically know in each group to keep them the same size. So we'll see if I turn my members on, they're all the same, 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 and those two are the same, and 50 by 7 flats. It's a bit small, I might change that up to 100 by 10s for those. So if I go and pick one of these, if I change that to 100, you'll notice they've all now changed to 100 by 10. So they're all 100 by 10. And if I reanalyze, scan for failures, interestingly I've found a few members that have just failed and no more in the old Appendix B, but I mustn't have put in the distances for these. The torsional distance should have been put in at 3.5. So back to here, move to the next failing, that's been fixed. Move to this one again. I must have redistributed when I reanalyzed. So if I auto size this one, it will in fact do them all. So let's move forward, and again it has accidentally forgotten that internal check. Yes, I'd put them on the rafters, I forgot to put them in the beams. They're just more exact to do them with the Appendix G. It's never really a problem with fully restrained members in the first place, but it's always wise to have it in there. So back to auto, and this member here again, it just needs resized, and just checking Appendix G is not a problem, and move forward. So reanalyze, rescan, and everything is fine. So we've scanned, turn off our member lengths. One of the great things we can do now is up here in this toolbar is we can turn on unity values. We can see that that's the most critical member. Woo. We can see that in every design group we have our most critical members, and we can see that no members fail. And of course you could print those out by just going right mouse click and print to send that out to your printer. The other thing we wanted to look at was how you print out the detailed output. So print design output. First of all, include everything, remembering that each member may have 3, 6, 8 checks on them. So they have a beam check and 2 Appendix G checks. These are the beam plus about 5 Appendix Gs. And I can select and deselect all the members as I see fit. I can also say only give me the critical portion, and I go auto select again, and it's for the members that have multiple checks on them. It's removing the superfluous lower unity checks on them, or in this case the ones that have the same unity check, just a different location. I can also say only for each section size select the most critical, so it gives me those ones there. So each section that was used, this is the most critical design check, and this is beautiful because this allows me to output a limited amount of data. So I'm going to print to my printer, and I'm going to print this list, and in my case to a PDF writer, and print, and I get 2 pages to get that whole summary. And then I'm going to print the detailed output and print, and I'm now up to 8 pages in total and 14 pages. So that's 12 plus 2. And if I just close the PDF writer, I'm going to save it on my desktop. And there's my summary, highlighting in bold the ones that are going to be printed out in details. And then you have your strut, your axial, your appendix G, your axial, your appendix Gs, all the detailed design checks on each of the significant members in each list. So that is your tutorial on simple frame analysis.